Hey guys, welcome back to question 3 for 2014 level 3 differentiation exam. So we'll get straight back into it from where we left off. Question 3. Differentiate y equals to the third root of x squared plus 4x whole thing to the power of 2. We need to differentiate that. So out of this form, we can't actually differentiate, okay? We need to make it in forms of a function and to the power of something, okay? We can rewrite this as y equals to x to the power of 2 plus 4x over, to the power of 2 over 3. The 2 over 3 means x squared plus 4x squared, but to the third root. That's what to the power of 2 over 3 means. Now we can use the chain rule and differentiate, okay? So dy over dx. Alright, it's a chain rule, okay, so you move the 2 over 3, so you move 2 over 3, and then multiply by the inside function, so x squared plus 4x. You move the power down by 1, and then you multiply by the derivative of the inner function, okay, so that becomes 2x. Oh yeah, yes, 2x minus 4. So basically, then you multiply by the derivative of the inner function. Then you'll get dy over dx equals to 2/3 of x squared plus 4x to the power of negative 1 over 3 times of 2x minus 4. And getting up to here, that's an achieved marks there. Find all the values for x, or which graph of the function y equals to x plus 32 over x squared has stationary points. Alright, for this question is pretty easy. There's two ways to do it. So once again, you can move the x squared up. So therefore, 32 times x to the power of negative 2. But I'm going to show you how to do it the quotient rule, because that's how that's the skill of the level 3 differentiation, okay? So dy over dx, so x, derivative of x is just 1. So 1 plus of. So once again, the quotient rule, so that's g dash times of f minus f times g dash, okay? Oh, sorry, I just said the exact same thing twice. G dash times f minus f dash times g over g squared. So basically that would become x squared times of 0 minus 32 times of 2x over x squared to the power of 2, so that becomes x to the power of 4. So dy over dx, we simplify, that becomes negative 64x, sorry, 1 plus of negative 64x over x to the power of 4. Alright, so you can cancel out 1x and 1x at the bottom, so therefore dy over dx equals to 1 plus negative 64 over x to the power of 3. Alright, so now when it says it has stationary points, that means the gradient is equal to 0. So we're going to substitute the derivative is equal to 0. So 0 equals to 1 plus negative 64 over x to the power of 3. Move the plus 1 to the other side, so negative 1 equals to negative 64 over x to the power of 3. So negative x to the power of 3 equals to negative 64. We're going to divide both sides by negative 1, so therefore x cubed equals to 64. And so therefore x equals to the third root of 64. So therefore x equals to 4. Alright, to get your x equals to 4 there, we'll just get you an achieve. Pretty straightforward there. Alright, moving along. For what values of x is the function f of x equals to 5x minus x ln x increasing? Alright, so once again, we need to find for what values of x is ln of x increase, x ln of x, 5, what am I saying? So when f of x, so 5x minus x ln x, when is that increasing? So we need to find the derivative first. So f dash of x that equals to 5 minus, so derivative of 5x is 5, so 5 minus, so we're going to use the chain rule here. So we use the chain rule, okay, so ln of x is our inner function and x is our outer function, okay? So the derivative, so basically it's f dash of g plus, sorry, f dash of g plus g dash of f, okay? So that's our chain rule. So f dash, so that the derivative of negative x, the derivative of negative x, okay, that just means it's negative 1, okay? So therefore minus it'll be just be minus 1 times of ln of x plus of so ln of the derivative of ln derivative of ln of x times negative x. So 1 over x times of x. So therefore, f dash of x equals to 5 minus ln 1 times anything is still that, so ln of x plus x over x. Okay, so f dash of x equals to 5 minus ln of x minus 1. Okay, so this negative here makes everything inside the brackets negative. Okay, so if we simplify this, f dash of x equals to 4. Why is it? Sorry, it's just ln of x there. Okay, so 4 minus ln of x. So when is it increasing? So that's when the gradient is positive. So therefore, f dash of x is more than 0. So 4 minus ln of x is more than 0. Alright, so if we move the negative ln x to the other side, it will become 4 is greater than positive ln of x. So now we need to move the ln to the other side. If we move the ln to the other side, it becomes e to the power of whatever's on the left side of the equation. So what I mean is, if I move the ln to the other side, it will simply become e to the power of 4 is greater than x. E to the power of 4, all you have to do is plug that into your calculator. So e to the power of 4, that's 54.6. So 54.6 is greater than x. However, we're not quite done yet, because we know that ln of a negative number doesn't exist. So for example, if you go to a calculator, try plug in ln of -1. You should get the error reading on your calculator. So ln of a negative number doesn't exist. So therefore, negative ln of x, so x must be greater than 0. Okay, so x is less than 54.6, but it is more than 0. And that is your final answer there. To get your final answer, it should be a merit question. It's a merit question, so therefore, it's a merit to get to the final solution. To get an achieved, it's a correct expression for the derivative. So if you find the derivative equals to 4 and minus ln of x, that'll get you an achieved. Moving along. A container is winched up vertically from point P at a constant rate of 1.5 meters per second. It's being observed from point Q, which is 20 meters horizontally from point P. Theta is the angle of elevation of container from point Q. At what rate is the angle of elevation increasing when the object is 20 meters above point P? Okay, so once again, we're going to follow through our steps for the rate of change questions. Step 1, identify what the question gives you. The question gives you container is winched up vertically from point P at a constant rate of 1.5 meters per second. So the container starts at point P and it's going to be moved up at 1.5 meters per second. So therefore, the height of the container is changing with respect to time. So therefore, we can say that dh over dt equals to 1.5. That's what the question gives you. Second step is to find what the question is asking you to find. At what rate is the angle of elevation increasing? A rate refers to time, okay? So therefore, it's asking you to find the change in theta over change in time. That's what we're trying to find. That's our end result. So now we have d theta over derivative of time. And we also have dh over dt. What do we need to multiply dh over dt with in order to get d theta over d time? So we don't want h, so there's no dh in our final answer. So we're trying to cancel the dh. We do that by putting dh on the denominator. So dh would cancel with dh. And what do we want to put in? What do we want to put to replace that dh? We should put d theta, because that's what we're trying to find, d theta over d time. So we're trying to find d theta over dh. That is our goal. So now we need to find theta in terms of h. As you can see, we have our theta here, and the 20 meters that never changes. So as you can see, so we can say that so basically we have 20 meters here, and we have h here. So opposite and adjacent, that's tan rule. So we can say tan theta equals to O over h, which is h over 20. Therefore, tan theta multiplied by 20. So 20 tan theta, I should write that as 20 tan theta. 20 tan theta equals to h. Alright, so good news is now we have theta and now we have h in terms of theta. However, we need to find theta in terms of h. Okay, so therefore this is wrong. So therefore we should what we actually should do, we should actually say that h divided by okay, so sorry. Actually, that it does work. So 20 tan theta equals to h. So therefore, if we differentiate this, we'll get dh over d theta. However, we want d theta over dh. Okay, so basically we're gonna differentiate 20 tan theta, and we're gonna find the inverse of it. Okay, so dh over d theta. Okay, that gives us 20 tan differentiates to sec squared. In case we're gonna say sec squared theta. So that's what dh over dq is. Okay, we know that from our trig rules that sec theta equals to 1 over cos theta. And we can simplify sec squared and make it, so sec squared, so this squared will be this squared as well, okay? So dh over dq, not dq, why am I saying dq now? Stupid. D theta equals to 20 times of 1 over cos squared theta. And if we simplify this again, we'll get dh over d theta equals to 20 over cos squared theta. Alright, so the good news now we have dh over d theta, but we need d theta over dh. So we're going to inverse both sides. We're going to flip both sides around. So therefore, d theta over dh equals to cos squared theta divided by 20. And that is our d theta over dh, okay? So therefore, we have our dh over dt, that's 1.5. And we have our d theta over dh, that's cos squared theta divided by 20. We need to multiply these together to find out d theta over d time, okay? Over dt, sorry. So therefore, d theta over dt equals to 1.5 times of cos squared theta over 20. Therefore, d theta over over time, that equals to 1.5 cos squared theta divided by 20. Okay, so at what rate is the angle of elevation increasing when the object is 20 meters above point P? So when the object is 20 meters above point P, that means the height is 20 meters, and we also know that the adjacent side is also 20 meters. So therefore, we can use our tan rule. So tan theta equals to 20 divided by 20. And that means that our theta should give us 45 degrees. So basically when the container is 20 meters above the air, our theta will be 45 degrees. That's basically what it tells us. So why are we trying to find this? Why can't we just find our answer immediately? So as you can see in our equation, we have 1.5 cos squared theta. The problem is that the question gives us the height, but it doesn't give us theta. That means we need to manually work out what is the theta at when the object is 20 meters above the ground, and we need to substitute that theta back into our equation, okay? So basically now we have our theta. We can say d theta over dt equals to 1.5 times of cos squared of 45 divided by 20. Alright, so if we simplify this, so cos 45 squared times you should get your answer as equal to 0.0375. However, don't forget your units, okay? So when you're trying to find the unit, read the question one more time. At what rate is the angle of elevation increasing? So rate refers to over time, and angle of elevation, that refers to degrees. So therefore, you're going to say that the rate of change is 0.0375 degrees per second. And that is your final answer there. Alright, so this question is a merit question. So finding the correct change in angle will give you a merit grade. To get an achieved grade, you're looking at correct expression for dh over d theta. So dh over d theta, that is that should be dh over d theta. That will give you an achieved grade. Moving along. A cone has a radius of 20 centimeters and a height of 40 centimeters. A cylinder fits inside the cone as shown below. What must the radius of the cylinder be to give the cylinder the maximum volume? Okay, so with this question, okay, so it tells you to find the maximum volume. First thing you do, go to your formula sheet, find what the volume is of a cone. You find that V equals to 1/3 of pi r squared h. Okay, so the logical thing to do now is to differentiate and then find the derivative and make it equal to 0. However, you don't actually have, you have two different variables, r and h. You have to get rid of one variable. Now you need to ask yourself, what variable do I need to get rid of? Read the question. What must the radius of the cylinder be? So therefore, you're going to write everything in terms of r. So we're trying to get rid of the h and make it in terms of r. So now that you know what you're going to find, so first thing is to figure out what you're trying to find. That's the most important thing. You find out what you're trying to find. Next thing is going about finding it, okay? Alright, so first thing you're trying to noting down the lengths, okay? First thing to do in this question, okay, you should find the slant length of the cone, okay? The slant length refers to this length here. And we can really easily do this by using our trigonometry rules, okay? So therefore, we can use that 20 and 40. So 20 squared plus 40 squared equals to our slant length. So we're just going to say our length squared. If we plug that into our calculator, so that's just 20 squared plus 40 squared. And we find the square root of that. That should give us L equals to 44.72. L equals to 44.72. That's this length here. So you're asking us, how is that going to help us? So how's it going to help us? So you're going to find a way, the best ways to find in terms of a right angle triangle. So as you can see here, so from here to here is r, while from here to here is 20. That means in between here, this length here must be r minus 20. Okay, that must be r minus 20. And because this is the height of the cone, this length here, this length must be h, okay? Alright, so we got that. So this bottom length here is r minus 20. We'll just get rid of these lines, it's a bit confusing. So you know what I'm talking about now. So that length there, from here to here, that's r minus 20, and the height is h, okay? So now we need to find one more information in order to find the relationship. So right now we cannot find the relationship because there's not enough information in our right angle triangle. Notice that we also have a triangle. Sorry, notice that we also have a triangle. Sorry, what am I doing? Also have a triangle that's from here to here. You know this length is 40, as you can see here, that's 40 centimeters. And we know that the horizontal length is 20 centimeters. And we can try to find out what this angle is by using our right angle triangle rules, okay? So this angle, we call that theta. We have 40 and 20. So 40 is the adjacent side and 20 is the 40 is the opposite side and 20 is the adjacent side. So we can use tan, we can use, no, that is not 40 actually. I realized that I made a mistake. Sorry guys, so I was being stupid, so. Once again, we're going to draw a line down, but we're going to use 44.72. That's what we're supposed to use. Sorry about that, guys. We use our 44.72, so we can use 44.72 is the hypotenuse, and 20 is our adjacent. So we're going to use the cos rule, okay? So cos of theta is equal to a over h. Our a is 20, and our h is 44.72. So therefore, we find the cos inverse of 20 over 44.72. Plug that into a calculator. Divided by 44. Get that your theta equals to 63.434 degrees. And that is your angle theta, okay? So now you have something to work with, okay? Now you have r and h, and you have one angle. So now you can say that tan of theta, so h is our opposite side, and r minus 20 is our adjacent side, okay? So now we can use our tan rule. We can say that tan of 63.434 will give us over a, okay? So h, therefore h over r minus 20. Alright, so now we need to find h in terms of r. So h equals to something, something, something. Alright, so first thing we can do is we can simplify tan of 63.434. We can simplify that into numerical form, and that actually equals to 2, okay? So therefore, you can say that 2 equals to h over r minus 20. You move the r to the r minus 20 to the other side, so that becomes 2r minus 40 equals to h. So now we have now we have h in terms of r, and we can put that back into our volume formula. So v equals to 1 over 3 pi r squared multiplied by 2r minus 40. So v equals to 1/3 of pi. We should expand this first, okay? So 2r multiplied by 1/3 of pi r squared, that becomes 2 over 3 pi r cubed minus 40 over 3 pi r squared. Okay, so now we have our v. Okay, we need to find dv over dr in order to find our derivative. So dv over dr, that equals to 2/3 times 3, that's 6 over 3, so that's 2 pi r squared minus 2 times the 40 over 3, that's 80 over 3 pi r. So dv over dr equals to 0 because it's a maximum. Oh, sorry, is it a maximum? Yeah, it's a maximum, so therefore the gradient at that point is 0. So 0 equals to 2 pi r squared minus 80 divided by 3 pi r. Okay, we're going to divide both, but we're just going to divide the whole thing by pi r. So 0 divided by pi r, 0 divided by pi r equals to 20r, not 20r, 2r minus 80 divided by 3. Pi r is gone. 0 divided by pi r, that's still 0. So 0 equals to 2r minus 80 over 3. If we move the 80 over 3 to the other side, so 80 over 3 equals to 2r. Now we're going to divide both sides by 2. So 40 over 3 equals to r. So therefore, your what must the radius be to give the cylinder the maximum volume? So your answer would be 40 over 3 centimeters. And that there is your final answer. And that will actually give you your excellence grade for this question. That's an excellence question there. So getting up to here will get you an excellence grade. To get a merit grade, you're looking for dv over dr correct. So dv over dr is correct. That'll get you a merit grade. To get an achieved grade, you're looking for correct derivative. So basically, once again, it's not really clear exactly what you need to do. But basically, if you show basic understanding of knowing level 3 derivatives, you'll probably get an achieved grade. Alright, so thank you for watching this video, guys. I hope you enjoyed this exam walkthrough. If you have any feedback, leave it down in the comments below. I thank you all for watching, and I'll see you in the next one. Thank you.